All right, guys, so I'm gonna go ahead, like I promised, at the end of class and record myself working through these notes on linear expansion. I'm gonna go ahead and redo this example problem since we were pretty rushed in class here. In this example, it says a 5-meter long rod is heated from 0 degrees Celsius to 100 degrees Celsius. The linear coefficient of expansion for iron is 12 times 10 to the negative 6 Kelvin to the negative first. Determine the change in rod length. We can recall that the coefficient of linear expansion can either be in Kelvin or in Celsius. And since Kelvin and Celsius have a 1-to-1 ratio, which means that 1 Kelvin is equal to 1 degree Celsius, we don't actually have to convert between the two of them, even though our change in temperature is listed in Celsius and our coefficient of expansion for iron is listed in Kelvin. So let's go ahead and write down the things that we've been given in order as they appear here. Our coefficient of linear expansion is 12 times 10 to the negative 6 Kelvin to the negative first. And then our initial length of our rod right there is 5 meters long. Our temperature final is 100 degrees Celsius, and our temperature initial is 0 degrees Celsius. So we plug this into our formula. Our formula, as a reminder, is change in length is going to be equal to our coefficient of linear expansion times our length 0 times our delta T, where delta T is equal to temperature final minus temperature initial. All right, making sure we can see all that perfect. So let's plug this into our formula. Our delta L, our change in length, is going to be equal to our coefficient of linear expansion times our initial length times our temperature, our change in temperature, excuse me. So our temperature final is 100 minus 0. This becomes delta L is equal to 12 times 10 to the negative 6. 100 minus 0 is 100, and 5 times 100 is going to be 500. So from here, we obviously need to put some stuff in the calculator, and this is where I think I lost quite a few of us in class today. So we have that coefficient of linear expansion, which is something that is written in scientific notation. So the first thing we need to do is put that, what is up front, that 12, and then it's times 10 to the negative 6. The easiest way to put things in scientific notation in the calculator is to press that second button and put negative 6. That second button and then that x to the negative 1, a double E above hand. That E right there means times 10. So when we press enter, you can see that it is this number as a smaller decimal, because that's what that negative means. We move that decimal to the left as opposed to the right. And then we can multiply that times 500, and that gives us our change in length. As McQuell said in class, that is a very, very, very small change in length, but it is still something that is relevant and good for us to know. So if I were to ask us the total length of our object after it had undergone expansion, we'd have to take that initial length and add it to our 0.06 meters, and that comes out to be 5.006 meters in length. I'm going to do the second part over here as a second video, so be on the lookout for that in Google Classrooms.